Good morning, everybody. This is a live extreme weather briefing as we have a lot to talk about, including an update on the smoke plume that is traversing across the central U.S. Thankfully, in the wake of that smoky trough, we do have improving air quality here across Colorado. You can see that massive smoke plume moving through the central U.S., even approaching the western Great Lakes there. Even my uncle in northern Michigan has noted an uptick in that smoke and a decrease in the air quality. And yesterday in Denver, it actually took over as the city with the worst air quality of anywhere in the world. And that is a city, of course, right next to these big time wildfires where you might be just outside of a city. You could certainly get worse air quality. But you can also notice an uptick in the smoke quality, in the smoke, and a decrease in the air quality again in the Mountain West areas like Salt Lake City, back to central and northern California, of course. But we do just have that little bit of a brief respite with the air quality here in Colorado. You can see that little green area right in the central part of that screen. That's right behind that trough that led to the severe weather yesterday across this area. There you can zoom out just a little bit. This is the great visualizer here at the ESRL NOAA website. This is HRRR forecast vertically integrated smoke out there, and that's definitely an issue for a large portion of the central U.S. Another issue is this large 2% area that stretches from Wisconsin through a large portion of Missouri into eastern Kansas. And you might wonder, how do you target within this very massive 2% area to maximize your chances of seeing a tornado? And that's one thing that we're going to be doing during this briefing, is picking out individual targets within this large 2% area where we think that there is a better chance than elsewhere of seeing a tornado. And yesterday we do have two preliminary tornado reports. I do think there was just the one tornado up there just to the southeast of Boscobel, Wisconsin, there in the southwestern portion of the state. Looked like a pretty significant tornado too. Radar showed that debris lofting up to about 20,000 feet. That debris ball was larger than about 2 miles in diameter, and the rotational velocity gate to gate in excess of 150 knots at one time during that one volume scan of that radar. Likely going to be an EF2 or greater tornado, but it does depend on if it hit anything to justify that type of a rating, or if it did sufficient damage to the vegetation. We also had some big wind and hail reports down there across western Kansas. We were breaking those down live. Even a couple severe weather and small hail reports down into the northern Texas Panhandle and northwestern Oklahoma. The severe weather and tornado capital in the world comes in with a couple of severe weather reports there as well, near the Enid area, pretty close to where Gizmo was born. The birthplace of Gizmo there in Enid, Oklahoma, and even a couple right underneath the core of that cold air aloft, a couple of severe wind and hail reports out there. But one tornado happened yesterday, and that's all it takes to cause big problems. It was a difficult one to see, largely wrapped in rain, but when it first touched down, it came down as a nice cone, condensed, and then poof, disappeared, but then came back again as a multi-vortex, a very large circulation too. The tornado cyclone with that was definitely a very large circulation, and then the tornado was a cone within that, but that debris definitely fanned out to a radius of larger than 2 miles in diameter, so definitely was a significant tornado. We'll see what the damage indicators show for that, as the National Weather Service is able to get out there and dominate that damage survey. So let's take a look now at the overall pattern. We'll start with the 12Z 3-kilometer NAM, high-resolution NAM here, and get an idea of what this upper-level pattern is doing here. We still have the same smoky trough centered over about Watertown, South Dakota, so far this morning. And just to the east of that, some decent mid-level flow across the target area. That's why there is that large 2% area. Anytime you get this sufficient bulk shear for even transient supercell structures, then there is a non-zero tornado threat, even a chance of a mesoscale accident somewhere within this target area. The best bulk shear is up in Wisconsin, in the northern portion of that risk area, where you get about 35 to 40, even 50 knots there at 500 millibars. A little bit less bulk shear down into eastern Kansas into southwestern Missouri and the southern mode of that, but still sufficient bulk shear, at least 30 knots throughout that warm sector. And now let's see how the low-level jet is going to evolve. That's at 15Z, so we want to get a little bit closer to initiation and a little closer to the apex of that trough. You can see the stronger low-level flow from eastern Iowa into central Wisconsin there. Decent southwesterly low-level jet up there, possibly contributing to some greater low-level shear across the Wisconsin 2% area, where there is a flash flood watch in effect as well for the threat of some training thunderstorms. And you still have 25 to 30 knots at 850 all the way down to eastern Kansas into southwestern Missouri as well. So could certainly be a bimodal type of a severe weather event with a slightly increased but a tornado risk up in Wisconsin into eastern Iowa, and then another southern mode down into eastern Kansas into southwestern Missouri as well. Looking down in general at the surface, we're just kind of looking very generally. You can see up basically the synoptic scale warm front up into central Wisconsin. More backed winds associated with that boundary in central Wisconsin. Due southerly winds, 5 to 10 knots out there. And even down into southeastern Kansas into southwestern Missouri, south-southwest surface winds at about 10 to 15 knots down there as well. So in general, let's take a look at the 0 to 1 kilometer EHI so we can see where the best overlap is of that low-level shear with the instability. And you can see in this area here across central eastern Iowa, in fact, is carved out by a massive blob of stable air there, likely an old MCS, but definitely drying out there across the entire state of Iowa into southwestern Wisconsin, western Illinois as well. Juicy environment, though, covers the state of Missouri down into southeastern Kansas at 18Z. Let's step forward in time up to about 21Z and see how this low-level shear evolves. Look at that, down into southeastern Kansas, into southwestern Missouri. Some definitely yellows and reds down there in that 0 to 1 kilometer EHI, showing a better co-location of that 0 to 1 kilometer storm relative helicity and the surface-based cape there. A little bit of a cape blob in central Missouri as an MCS gets going. And then up into central and northern Wisconsin, close to that synoptic scale warm front, it lifts up to northern Wisconsin. But you just have this stable air invading large portions of Wisconsin, Iowa, a large portion of the warm sector, tracking that warm front across northern lower Michigan through the Traverse City area, though. Wonder if there could be a mesoscale accident off that sea breeze front there in the Traverse City area along that warm front, and when you get those southwesterly 850s at about 40 knots. My Uncle Bruce reported rain so far this morning in the Traverse City area, so I may let him know that there is a chance of a mesoscale accident from northern Wisconsin across northern lower Michigan, and near that casino there in Pittsburgh, Kansas, down southeastern Kansas into southwestern Missouri, far northeastern Oklahoma, maybe the Miami area there, along the southwestern periphery of that complex of storms could also be interesting. And here are the dew points dropping into the upper 60s in that hole there of relatively stable air dominating Iowa into southwestern Wisconsin. But then you get the standard mid to upper 70s dew points there in Illinois. And then you can see this hole with the cape with the complex of storms that's forecast to evolve across central Missouri. I can see the southwestern portion of that complex back behind it where it destabilizes out there. Southeastern Kansas, southwestern Missouri being an interesting target as well. And there you can see that cape pull across central and eastern Iowa into western Wisconsin, southeastern Minnesota there as well. Just a little bit too dry there with those dew points mixing out into the upper 60s on the 3 kilometer NAM. You do have decent cape though there from central and northeastern Wisconsin, and a stripe right along that synoptic scale warm front extending across northern lower Michigan as well. Could be interesting. And then you got that complex of storms that is forecast to evolve down there in central Missouri and get reinvigorated a bit. Just starting to develop by the midday hours there from Springfield up to Rolla area, and then expanding into a complex of storms by 21Z. Definitely some severe weather, flash flooding possible with that. But then look at that Cape hole there across northeastern Iowa. That's going to be a mitigating factor for severe weather across Wisconsin, across that northern mode. That stable air, that big Cape hole up there, lifting northeast. It does convect, though. That better Cape across northeastern Wisconsin does convect across that synoptic scale warm front. Green Bay area, Oshkosh up there, convects really before the arrival of that dry air aloft. And then you get that massive complex across central eastern Missouri, central southern Illinois as well. But I would watch back behind that complex later on, late afternoon and evening, southwestern Missouri into southeastern Kansas. Certainly could get interesting there as well. But the thermodynamics are quite complicated. The best low-level jet is nosing into northeastern Wisconsin up there and northern lower Michigan, banking up against that synoptic scale warm front from northeastern Wisconsin across northern lower Michigan. And then you get a bit of a reinvigoration of that low-level jet, southeastern Kansas into southwestern Missouri, but you do have some anticyclonic curvature even to those 850 winds down there. So once that complex forms into central and eastern Missouri and also western Illinois, it's very possible that there could be a suppression of that convection back behind it, southeastern Kansas into northeastern Oklahoma. So it would be more of a gamble, but if you live locally there in southeastern Kansas, I'm talking to you, Tyler Constantini, you may want to keep an eye on that area back behind that complex for the development of some severe weather. Just cherry picking a sounding there in the middle of that low-level jet in northeastern Wisconsin. Looks bad at 0Z, really tainted by that convective blob that develops. Little hodograph there. Look at that little thing. Cute little hodograph happening. Let me make sure I'm even live. Sometimes I forget to turn on the live here. Going back to the models. That even though that hodograph is small, just below my head, it does have some non-zero storm relative helicity. Not quite as strong of a low-level jet as indicated at 0Z just before that complex gets going. A lot of times those complexes can kind of fuel their own pressure falls and fuel their own low-level jet that will act to sustain those. But 86 over 76 out there, a lot of Cape in northeastern Wisconsin, decent directional shear. You could have a little bit of a stronger low-level jet, at least on the 3-kilometer NAM up there. But as you go a little bit further at 22Z at about 5 p.m. Central Time, you do have an increase of that low-level jet. And usually you want to play the nose of that low-level jet up there. So I do think that this central and northern Wisconsin target seems to be shaping up just a little bit better. Right along that synoptic scale warm front, the 850 low there over south central Minnesota. I usually love chasing these Midwestern setups, these monster complexes, mega shelves, flash floods. We had flash flooding last night in Omaha, Nebraska, with a large rainfall footprint in excess of 4 inches out there. Many of the rivers flowed over their banks, rivers going down the streets in downtown Omaha, even invading some of the parked vehicles there along the highway. So a flash flood emergency was issued down near the Omaha area there yesterday. Today, likely going to be more flash flooding. Greatest flash flood threat looks to be in central Wisconsin, right along that synoptic scale warm front and where that low-level jet is forecast to invigorate. There's that complex of storms by 5 p.m. going up into central Wisconsin, extending toward the Oshkosh area, eventually pushing toward Green Bay. And maybe the southern portion of that complex of storms, like we saw yesterday, could see the development of a supercell storm that is able to anchor in that low-level jet along that warm front. Could get 1 or 2 tornado reports again along the southern edge of that complex. That's at 5 p.m. I want to see if there's any signal of some convection developing further east along that warm front across northwestern lower Michigan. 3-kilometer NAM doesn't show it. Does have a complex over Lake Huron there. and near the core of the 850 low, possibly some isolated severe weather again across south central Minnesota into north central Iowa. But here's this complex of storms here. Could be a nothing burger. There you can see this little MCS that moves from central Missouri into eastern Missouri, and then by 7 p.m. central into western Illinois there. Maybe some more robust development in a weakly sheared environment back across north central Iowa. Maybe some storms again back toward the Omaha area there. But boy, it looks like it's MCS day today. Across the Midwest, back into eastern Kansas and Missouri as well. You can see just not a lot of favorable non-zero EHIs there by 0Z with that evolving complex of storms. A decent environment here pooling across northeastern Wisconsin, but then that complex forms, the anvil shadows get rid of all the instability, and the whole entire thing just kind of falls apart in terms of tornadoes. The best soundings out there are in northwestern lower Michigan. Best photographs there as well, with a lot more easterly winds in the vicinity of that warm front. Look at those low-level winds there right at the due east, shifting over to a southwesterly wind at about 25 to 30 knots, and then west-southwest 35 to 40 knots just above that. Not a lot of low-level instability there, though. A lot of cloud cover being analyzed by these models. You can see the very close overlap of the green dew point line with the temperature, indicating saturation up through at least a kilometer or two. But you do have a nice photograph up there in the Traverse City area. Maybe some water spouts up there. Maybe if a supercell can develop on that lake breeze, I could see a chance of a tornado or two up there. Definitely the best overlap of instability in that low-level shear on the other side of northern Lake Michigan across Traverse City. But definitely a decent environment across Green Bay. Could get a mesoscale accident if a supercell is able to thrive. On the other side of the lake, though, those photographs are a lot more straight line in appearance, not as much curvature, not as much in the way of strong easterlies in the vicinity of that warm front. You do have much better low-level instability, though. Those low-level lapse rates are a lot steeper there with more surface heating and less cloud cover across northeastern Wisconsin. But it does look like more of a complex forming, as is the case down here in central Missouri as well. Big complex forms. Slides out to the east through the St. Louis area into western Illinois. Flash flooding potential there. And that 2% extends even behind that complex of storms into southeastern Kansas and southwestern Missouri. If those anticyclonically curved low and mid-level flow and the subsidence associated with that can be overcome, then there could be some isolated severe weather southeastern Kansas into southwestern Missouri as well. So let's look at the HRRR. It does have a dry bias with it, but usually this time of year in the Corn Belt, the dew points are so high that even a dry bias has a hard time getting through. But you could definitely see that blob of reduced CAPE really getting really prominent in the HRRR with that runaway mixing that happens a lot. Mixes those dew points down into the low to middle 60s out there, central northern Iowa, southeastern Minnesota. A little bit of a blob of decent dew points and CAPE across northeastern Wisconsin and along the warm front into northern lower Michigan. I do want to see if the HRRR convects that warm frontal zone in northwestern lower. Probably just a little bit too much cloud cover up there. But that I do believe is the best forecast soundings that I've been able to find are across northwest lower. And the HRRR does have a hint at a storm forming south of the warm front down there in central lower Michigan out near the Houghton Lake area. But look at this mega complex that forms in that favorable, juicy environment with those mid-70s dew points and at the nose of that low-level jet up here in northeastern Wisconsin. This is at 7 p.m. Big rainmaker, a lot of lightning, a lot of thunder, some flash flooding moving into the Green Bay, Oshkosh area out there across northeastern Wisconsin. And then you've got the HRRR shows a couple of rounds of complexes of storms developing. The first one by about midday into the early afternoon forms across central Missouri, lifts up into central Illinois. Then a reinvigoration of those storms across central Missouri. Certainly could be some flash flooding associated with that. But there's that initial complex moving into eastern Missouri, western Illinois. And the HRRR does convect that favorable unstable environment down there, southeastern Kansas, into northeastern Oklahoma. There's 0 to 3 kilometer EHIs in general show a kind of favorable overlap of that instability and a low-level wind shear, 0 to 3 kilometer shear out there. Not a ton of 0 to 1 kilometer SRH, though, back behind that initial complex. This is all inflated because of the cloud cover and precipitation there in central and eastern Missouri into western Illinois. Just not a lot of 0 to 1 kilometer shear, but there is a chance of severe weather out there. A little cute little photograph, 91 over 72. Cloud bases are definitely low enough to get a tornado threat. South-southwesterly winds. Not a lot of strong magnitudes or directional shear there in the lowest 1 or 2 kilometers, but still enough to generate a 2% risk. If you can get a storm really turning hard right and moving more southeast at about 20 knots, it'll be able to squeeze out a little bit more low-level shear. But your 0 to 1 kilometer SRH of about 30, way below that, about 150 that you really need to have a non-zero tornado threat. And even your 0 to 3 kilometer SRH at about 100 is not great there. But the HRRR does convect that zone. And if you can get that storm to turn due south in that environment, down into southeastern Kansas, definitely worth chasing if you live in that area. If you frequent that casino there in Pittsburgh, if you live in Pittsburgh, southeastern Kansas, you definitely want to chase those explosive updrafts. And who knows, maybe even a little outflow boundary will be able to extend back behind this complex that's going to develop around midday in central Missouri, and could be interesting. So really that large 2% area is quite aggressive. You may just want to have a large C-text area, but maybe up there near Green Bay out ahead of that complex, or on the south end of that complex into central Wisconsin, or if a renegade storm is able to develop along that warm front near the Traverse City area, far northern lower Michigan off of a lake breeze front, could happen. Really, I think the greatest risk is going to be flash flooding across central and northern Wisconsin there. Let's look at some of the rainfall here as generated by the 3 kilometer NAM. Let's get away from this model that is the HRRR. So here are the QPF. This is the accumulated precipitation here by the 3 kilometer NAM. If I have it frozen. Ooh, there it is. There we go. So this complex that develops middle of the day into the early afternoon and moves into western Illinois is not as prominent on the 3 kilometer NAM. But late, closer to 0Z, it also convects that southeastern Kansas area, dropping over 4 inches of rain there. So southeastern Kansas, Parsnips, Chanute, Pittsburgh could certainly get some flash flooding down there with that southern mode behind the lead complex. And also some big totals, 3 to 4 inches being indicated there along that warm front with that complex that develops across central and northern Wisconsin there. And then extends across northern lower Michigan. Definitely some flash flooding possible as well across northern Wisconsin with that complex of storms on the nose of that low-level jet. But you do have the better wind fields even overnight across northern lower Michigan. But the instability just isn't going to cooperate out there. Too much cloud cover. And that's probably contributing to the favorable soundings across northern lower Michigan, even though the 3 kilometer NAM by a 1Z still has Traverse City at about 80 degrees up there. So definitely a warm, juicy environment out ahead of that complex of storms. Probably overnight tonight, it's going to migrate across northern Lake Michigan and northern lower Michigan, and could even see some flash flooding out there as well. Does warm up into the lower 80s along that warm front into Traverse City by 6 p.m. So that warm front lifts just through Traverse City, spikes those temperatures into the low 80s there. Very humid, warm day across Traverse City after some morning rainfall. And then you've got that complex of storms getting going across central northern Wisconsin. And a lot of the models are showing this southern Minnesota, northern Iowa mode also convecting robustly and producing some flash flooding out there near the core of that diffuse trough. And then tomorrow, looks like the Dakotas have another marginal risk of severe weather. I've got my varsity tutors class on Tuesday on wild summer weather, monsoons, flash floods, and hurricanes, 4 p.m. Eastern Time. Free class on varsity tutors. I'll be posting that sign-up link tomorrow, the day before that class. And then after that, I'm either going to be chasing the tropics, chasing hurricanes, if they are going to be threatening the U.S., or I'm going to be chasing a very invigorated monsoon again in the southwestern U.S. It looks like the middle of August that's going to reinvigorate. Here's a quick look at the 5-day graphic for tropical development. A couple of them show a 40% chance of development in 5 days. This one's probably going to have trouble over the greater Antilles out here, but still any of these could pose a threat to the southeastern U.S. One thing I'm noticing, quick glance, is we do have a strong subtropical high across the subtropical and northern Atlantic, but the western edge of that Bermuda high extends all the way into the southeastern U.S. again, like we saw last year, and that would favor a lot of these tropical systems to continue west into portions of the Caribbean, maybe even the Gulf of Mexico, especially if that is able to last throughout the fall. Then we'll likely have an impactful hurricane season for the U.S., depending on if that Bermuda high is able to extend into the southeastern U.S. And if persistence is any indicator for the rest of the season, then I do think that it's going to be active in terms of U.S. impacts of these tropical cyclones as well. So I'll have to decide between intercepting the tropics, working the invigorated southwest monsoon again, those flash floods and debris flows, or do I do the late season ridge runners, derecho potential up there in the upper Midwest that we're going to see for the next several days. So after my class on varsity tutors coming up here, that's when I'll be deciding on that. So thank you everybody for tuning in to my weather reports. Again, the Storm Prediction Center has a large 2% area from the Green Bay area all the way down into southeastern Kansas. But the greatest threat looks to be flooding across northern Wisconsin, central northern Wisconsin, and also southeastern Kansas, maybe even central Missouri into western Illinois as well. And maybe a mesoscale accident out there, 2% tornado risk within, so I'm going to be keeping an eye on it. And I will go live if needed, like we did yesterday for that single tornado up there in southwestern Wisconsin that did cause quite a bit of damage. So thank you everybody for tuning in to my weather report, and have a great rest of your Sunday.